Hello everyone, this is Muhammad Yazdi, and in this video tutorial I will be talking about modeling this table. Basically this video is a collaboration video with Kinetic Architecture, Leo Diego. So check his channel. He has very great videos about how you can model control table, a waffle structure, brick walls, and recently added a nail wall, which you can learn how to use graphs. So after talking with him, we decided to record two different methods to model one thing. So in this video I'm going to model the parametric precedent 1 contour table, and I encourage you to check his video out. He has used a great method to model the table, but I'm going to use two different methods to model the table again, so it's just an extra exercise. As you can see, I have modeled the table. Here's two ways I'm going to use. One is a simple one because I didn't divide the surface, I just deformed it, and the second one is a little bit advanced because I've used more things like dispatch and how we can let me just show you this part, how you can define two parts and combine them and control them individually. So you can just deform this one separately than the other part of the table. So basically the first method is about whole of the surface. Let me show you this. So I'm going to model all the surface here, but because I'm using a simple graph mapper for this, you can see that it will control all the surface structures. So this is the first method I'm going to use, and secondly I'm going to go advanced and tell you how you can just dispatch the pattern, use a pattern for dispatching, control both parts, how to relate those parts together so they move exactly the same at the same height or whatever you're trying to do. So let me start by first of all, check this video out and see how Leo's going to model this table, and this will be another exercise for you. So what I'm going to try, what the start of the video tutorial will be is to define a surface, and let me just show you from the top. Okay, first of all I'm going to make a rectangular surface, divide it into points, so we have a cloud of points. Then I'm going to define a point attractor in the middle and make a move on the points based on their distance from this point. So basically this will be a point attractor, so it will move those points based on the distance between the attractor points and the grid. And we will use graphs and the techniques I have talked about in various Grasshopper commands, but basically in the advanced section you will see new commands coming up because I haven't talked about them in the Grasshopper commands yet, like dispatch and those things. But this video is going to cover the whole procedure of making the table, and after moving those points we're going to make the surface. So the surface will be produced. So after that we can go into the mesh part and make a mesh table, and then use counter to define the table, because we need those parts as you can see here in this picture. We need those filleted corners, and I'm going to talk about mesh and how you can use mesh to do that. It's a simple one, but it will just hugely change your thinking and how you think about modeling. So first I'm going to make a simple rectangular surface. So I'm going to do the primitive part and use plane surface, and let me just put bifocals so you can see the commands. Okay, as you can see here, it produces a plane surface in the plane XY. So we have an XY plane, and the size is minus 10 to 10, because if you have a C-plane or a plane here, this will be minus 10 to 10, and this will be again minus 10 to 10. So we are not going to be stuck in the domain part. So I'm going to show you how to use a simple method to avoid the domain in the plane surface. First of all, if I just connect a number, because as you can see here, this needs a domain input, but I'm going to give it a number. So what actually happens is that Grasshopper thinks that you're saying 0 to 25.5. So this is a simple way to make a domain without giving the minimum part of the or the start number of the domain, and just give it a number. Okay, the second number, I'm going to give it to the Y again, so it's a rectangle. So here we can change the size. You can give it two different numbers to make it if you give it a one number, it's going to be a square, and if you give it a second number, it's going to be a rectangle. So you can change the size of the plane surface. Okay, I'm going to work with the square. So the next part is to divide this surface into points and make a point cloud. So I'm going to do a surface and use divide surface, or you can just simply search for divide and go for divide surface, doesn't matter. And I'm giving this surface, and the U count and the V count is the number of the points in the rows and the columns. So we're going to go with a high resolution point cloud, because we need all the information about the sine wave we're going to produce, and so we need a lot of points to show those curves. Okay, the first point about divide surface is that what happens about the outputs. There are two different commands in Grasshopper in the utility surface utility. Is they are divide surface and surface frames. As you can see here, we have a divide surface, we have surface frames, and both of them will produce grouped outputs. So if I give this to the UV, you can see that the output is a frame. It's a plane basically. But what I'm trying to say is that, check out the outputs. Let me just show you. If I zoom in, you can see that the output is about 31 groups and 31 that's a 31 path and a 31 item in that. So what has happened is that divide surface and divide surface frames is going to make columns and rows of information. So this is the first, let me show you, that's the first group, and that's going to be 0, 1, 2, 3, 4 to 31, and maybe this one is like the sixth group, just saying, and 0, 1, 2 to 31. So it's dividing the points into columns of information, but we don't need that, because we are going to handle these points as a whole group. So it must be something like this, a whole group. It's like a 0, or it could be like 0, 0, 0, doesn't matter. Okay, and that doesn't matter if you have multiple zeros. It's how Grasshopper handles, I call it time. It handles how something is before and something is after, so that's not the point. I'm going to destroy those paths. So what I need is to say to Grasshopper that we don't need those paths. We want them to be into one, and all of them be into the first group 0 0 0. So, oh, sorry for that. I didn't notice that there's a semicolon instead of 2 points. Okay, so I'm going to right click and flatten the output, the points. We don't need the normals and the parameters, so I'm just going to flatten the points. So you can see that 961 points in a whole group. If you want to see that, you can go to the params menu and choose panel. That's a good habit, to use panels and connect the outputs to the panel so you can see what's in the output. So let me just remove the flatten, and you can see that the points are in groups, so you can see that. And if you want to see more information about the paths and the lists, you can go to the param viewer tool and just connect it. Okay, you can see that it has 31 path and 31 items, and you can double click on it and show it as a graphical interface, and here you see that the data is just being into the columns of 31 path. Okay, so when I just right click and flatten it, you can see that there's one group, all of it is in a single 0 group, and that's because I've just flattened it. If I okay, if I use flatten tree, that's just a technical tip, that you can see that there's a path here, and you can choose which path it's going to be in it after it's flattening. So if I give it something like 7 here, you can see that it goes to the 7th path. That's useful, but I'm going to talk about that later in the Grasshopper course, which I will talk about replace paths. You can use it as a really advanced tool to just make those paths align again, relative item or relative items, and split tree. Those are really great tools that, if you understand the paths and the lists, and it's really, I don't want to say it's a difficult one, but it's maybe alien, and most of the architects don't know what's going on. We didn't have that in the modeling of before, or when we modeled with AutoCAD or Studio Max. We didn't use numbers or path for defining the geometry, but here we go. We need that because if you understand the underlying thing that is under the path and index of the Grasshopper algorithms, you're going to really control your data. Okay, so what I'm going to do is to put a point here so I can move it. I've talked about that in evaluate surface, so if you want to know more, you just go to the Grasshopper commands and check evaluate surface. I've talked about it, so I'm going to skip this, but I will talk about it a little bit in detail. So I'm going to give the evaluate surface to the plane, and I'm going to extract a point which will move in this plane. What it needs is a UV point or UV coordinate, and I've explained about UV coordinate what it is, so I'm not going to talk about it here, but you can use a MD slider. Okay, and that MD slider is a UV coordinate, a ready UV coordinate, which you can use, but always remember that you have to right click on the surface and reparameterize it, because the surface has various domains, and when you reparameterize it, you have a simple 0 to 1 a domain. Okay, so I'm going to move this MD slider, and you can see that the point moves. So we can actually change this model. Maybe after I finish it, we can move this hill over and see how the table would change. So let me just continue with that. Okay, we can go and delete that and put an MD slider right here. You can also use a vector and a construct point. I've also talked about it about value at surface command, and I usually change this x coordinate to u and change the y coordinate to v, because I wanted to repeat that in my mind that it's a uv coordinate and not an xyz. So let me just a 0 to 1 uv, and you can see that you can control it by a construct point also instead of the MD slider. So you can choose what you want. This is a little bit of an advanced approach, because you can just control exactly what you want and what the location of the point is. So I can give it a 0.5 and a 0.5. Okay, so after going for a point attractor, we have to compare these points to the evaluated points. So I've talked about this in a video in orient direction. So if you have seen the orient direction video, you will understand what I'm doing. I'm just comparing these points here, which are a grid of points, and the point attractor. So I'm going to compare those. First of all, what we need is a distance. We can find the distance between these points and the point attractor, and here we have the distances, and we can use it to move the points. So if I give it a move to this point about a z direction and use exactly the distance, you can see that the points are going up. Okay, and that's not a really good one, but it will show you what happens when you just use the distance to move a point. So if I move this, you can see that this surface is, the point cloud is just updating. And okay, so what we need here is a little bit of control, because first of all we need this one to go up and the maximum height to go down. Another one we need is to control the distribution of the data, because you can see it's a linear data, it's changing just a linear way, and we need it to be something like this maybe. So we need it to be not linear but a distributed, like sine distribution, Bezier distribution, whatever you want. I've talked about that, and we used remap. If you watch several videos in the website, you can see that I have used remap to just scale the data. I will put this tool, because I've made it from the remap numbers of Grasshopper, but you can download it in the description. But if you have watched my previous videos, perhaps you have downloaded it before. Okay, so I'm going to give it a 0 to 1. This was a technique. You can remap your data, whatever it is. Maybe it's a sound, even it's an input from an Arduino kit, doesn't matter. You just remap it to 0 and 1 because you want to use a graph mapper. And I've talked about the graph mapper technique, because you can just make it you can change the data from linear distribution to something that is not linear. So this is what I'm going to do. Okay, so the technique was like this: a remap to 0 and 1. You just don't need to change these. Graph mapper, so you can give it a different distribution, and again a remap. This is what you need, because you can change the minimum maximum of the height of the points. So This is really easy. You can give it a number, and let me just copy this. Okay, you can see that I'm going to control those points, and if I change it to maybe something like this, you can see that we have the top here. Okay, that's not exactly what the table looks like, right? So what we need here is a graph mapper, something like a sign, and we can move these handles and see that what happens. Okay, you can see that the distribution is changing. It changed from let me just turn these off. It changed from a linear distribution to a sign, and what is actually happening is that those points, let me just show you in diagonal manner. So it's these points, when they're just going further and further, they're going to go up and again come down. So that's exactly what's happening. You can see here, and this is the location of the tractor point, so it's giving it a sign. This is a technique you can use, and the best part about the graph mapper is that you can use multiple graph mappers. So let me show you. If I just go and give it another graph mapper, you can just increase the points so you can see the results. And let me change it to another distribution, a Bezier distribution. You can see that we can control those sign. So this is a great one if you just want to make I say amazing distributions, because you can't produce these with normal series or I don't know datas, but graphs can easily change your mind and change how you think about data. So what happens is that the number comes here and it's projected into the graphs. It goes to the second axis. It again comes here to this the second graph, and it's just going to project on the next graph and project on the second axis again, and this is the number. So it actually goes two-way to have a new number, and it's just distribution, and you can understand that we are combining these two graphs. So if you had let me show you, if you had a Bezier in the start and then you had a sign, okay, you can see that the result is different, because first of all you had made the Bezier distribution, and second you have made the sign. So this is important. Let me show you. The Bezier distribution is great. You can use it to produce awesome distribution of the points moving, and you can see that this is the okay. Let me return to the sign Bezier. I'm using Control Z to go back. You can see that if I change this point, we will have different results. So it's a great one, and you can see that it's cool. We will have many possibilities for this table. Okay, so let me just go to the center. Okay, that's it. We had the surface. Now we need to just move these. We need to put a surface from the make a surface from these points clouds. So I'm going to the surface, and I'm using the surface from points, and I'm giving it to the points, and there's a U count. What it says is that how many rows of points you have in the U direction, and we have made that in this divide surface thing. We gave it maybe, okay, let me show you this. If I go and make it 3, let me show you this. Okay, if I give it a 3 division, you can see that we have 4 different points. That's because when you divide a surface into 3 parts, perhaps you have 4, so we have one more than this number. Okay, what we can use is to give this number to the u count and make it go up, because it's not 49, it's 50. I'm going to go into the expression and use expression and give it x plus 1. Okay, I'm going to preview off this, and you can see that the surface is just being created. And okay, you can see that it's not the ideal solution, but it will give you a fast way to produce the surface. You can also use a cage edit in Rhino. Let me use bounding box and just system and a 4 4 4 1 2 3 4. Okay, that's okay. 4 points in x, y, and z. And you can change this. Remember, you can use these points and just move them up and produce different results, even if you had made these in Grasshopper. So I'm just going to change this. You can see that, and let me scale this down. And this is another surface you can use. You can see that. Okay, and we can rebuild that into fewer curves, and maybe 30 to 30. Okay, and you can see that the surface is just in a new form. Okay, you can combine this with cage edit in Rhino and get the results. Okay, back to our work. What we need is to produce the table, and in this tutorial I'm going to use the graph mapper technique, and I know that it's not exactly this surface. I'm going to explain about it in the next video. So what I'm going to do is to give it something like a fillet view. Something we need is like this. How can we produce a surface with a filleted edge or the corners? It's a simple one. If you have a NURB surface, exactly what I have here, we can go to the surface, to the okay, we can go to the mesh. We have to make it a mesh because mesh uses many methods. You can use plugins into mesh and make the mesh smooth, you know. But when you're using NURBS, you're really dealing with UV curves, so it's a little bit difficult to control the UV curves. I'm going to go to the mesh and utility and give it a mesh surface. If you have a pure NURBS surface, you can use the mesh surface tool to make the mesh look like exactly the surface. So I'm going to give a UV count. The more the better the surface will look like, the main surface, because we have more interpolation data. And you can see that that's a mesh result. We can use it in other softwares that use the mesh-based modeling, like AutoCAD, Revit, or whatever you're doing. Okay, so let me go to the second stage. When you enter the mesh part, a really important tool you have to use is a plugin called Weaverbird. So basically this plugin is going to change your mind about mesh modeling Grasshopper, because Rhino is really not too strong in mesh modeling, and it has its weaknesses. But in Grasshopper, if you use the Weaverbird, you can just download it. I will put the link into this video. You can download this plugin, just install it and reset your Rhino and Grasshopper, and when it comes up, you have a set of tools that are incredible. You know, you can extract meshes, you can use to make holes in your meshes parametrically, and that's a great thing, because we have Launchbox, a plugin for NURBS, because It uses NURB surfaces to produce panels and structure, and now we have Weaverbird that you can do great things with mesh. And the first thing I'm going to do is to extrude the mesh. You can use Weaverbird's mesh thicken, okay, and give it a distance 2.5, and let me just turn this off. You can see that this surface is, the mesh is just thickening, and if I bake this, you can see the result. Okay, and when we have such a thing in mesh, we can easily smooth the corners by just using a tool called Weaverbird Catmull-Clark subdivision. So what I'm going to do is to use, you can always use this Weaverbird Catmull-Clark subdivision to just simplify the mesh and easily smooth the mesh. What it does is that it uses a simple algorithm, and something like this. If you had edges here, okay, and there's an edge here and there's an edge here, if we just connect a portion of this edge to the neighbor, we will have something like this. And again, if we just zoom in and go and continue this algorithm, and this edge to this edge, we connect it, this edge to this edge, and this edge to this edge, and this edge, you will have a smooth edge. So it's not a really something that you can't understand. It's a simple smoothing algorithm, and you can use it. Okay, I'm going to use that mesh and turn this off. Use a 2 level of smoothing. You can see that it's happening, and if you just put it to 3, it will be better, but I don't suggest that you go further, because it will be just many faces of meshes, and you need a low poly mesh to just work easily as a parametric design method. Okay, here we go. We have the mesh, and you can see that it's just ready for making the sections. So I'm just going to go and type CONT in contour. That's the shape we're going to intersect with the planes. The point that we are going to start it is 0, 0, 0. That's the default one. Okay, we don't change that because our model is basically starting from 0, 0. Okay, and the direction is maybe X, and the distance we can choose to maybe 2.5. Okay, let me just turn this off, and you can see that we have made the surface. Okay, that's the contour part, and you have to make the solids. So that's a really important thing, because you can see that when it just intersects with the mesh, it will reach a point that it doesn't catch the end. So you can change this number to have a great result. Maybe you have to have an even number. So if I give it an odd number, you can see that it always has problem, but if you give it an even number, you will always have a good result. It's also based on your plane surface. So if I give it a 52 size and divide this, because we have a 52 length for the plane surface and a 52 for that, we can divide this to maybe 10 parts or 100 parts. Doesn't matter. You can go to the math and choose the division, and let's go here. Okay, that's another method you can use. You can just say I need 20 parts, and it will give you a number. Okay, 2.6. We can give this to that. Okay, and this is another method. You can just exactly have the exact curves you need. Okay, so after that we have to make the surface. There's a great tip here. There's a great method you can use, because this result, let me zoom in. This result is a polyline. You can see here, it's a polyline. And if I connect a surface to this, I don't know if you have just watched the video about Metaball. I've talked about the Metaball custom and talked about how you can rebuild the curves that is a polyline to a curve. So I suggest that you watch the Metaball custom video. But if I connect the counter to the surface to make a surface from those polylines, you can see that it's gonna take a while. Okay, and 97% of the energy is just consuming here. You can see that at display, canvas widget, and the profiler. Okay, so what I suggested in that video is that to use a rebuild tool, rebuild curve, and rebuild that to a 3-degree NURBS curve, and just the counts can be like, okay, let me just turn this off. Okay, the count should be a number that a good number that will produce exact result, because if you just decrease the number, you can see that that's not exactly what we want. Okay, I'm going to increase that, and at the end we have a NURBS curve. That's great. We can just connect the surface to that, and here we are. You can see that that's like 120 milliseconds, and that's really fast compared to that polyline thing. And next we can just extrude it and into the X direction and have the exact distance for the extrude. Okay, I suggest that you just choose an even number here, and you can see that, okay, just increase that. You can see that the result is coming out. This was the first exercise you could do. Okay, let me just close this and show you that we have produced that. Okay, and this is simple, but we don't have a control on this part. We need a control for this part, and we need a control for the corners. So I'm just going to change this method, but this is a great one if you want to produce a simple and a single graph mapper method. So I can just come here and let me just disconnect the Catmull-Clark subdivision. Oh no, okay, we can just disconnect the contour and just show the Catmull-Clark, and you can see that if I go to the display, you can use a custom preview tool. Okay, custom preview, and just connect this. We can move the point and see the results. This is the parametric part. You can just change it, have a new bench. You can just change these. It's just infinite possibilities. You can change all the graphs. You can see what happens. Okay, you have to be careful about the corners because they can just have problems with the meshes. So that's mainly because the thickening part is just important. Okay, so you can see that I can produce many different results, and just connect again that capture to this part, and let me just connect the custom preview this time to the extrusion and make everything go off. Okay, you can see that this is the result, because if you're going to change the position of the point attractor, and there's all going to run a contour, a rebuild curve, and a exact, and the most important is the extrude one, because when you're just extruding and moving the attractor point, it will just slow down and you will need to wait. But why should I do that? I just disconnect the contour, I show you the Catmull-Clark. We can just connect the custom preview to see the surface and change the results. Okay, and you can see that it's going to be fun. You can just change that. You can change the thickness, or you can just increase it. You can see that's inflating, and perhaps that's not a good mesh. You can't 3D print that. Okay, so this is the first method. The second method will be just easy, but because I'm not going to talk about the surfaces and the meshes and the mesh thicken part, but I'm just going to move before the surface from points and talk about that. How can we control those points? How can we control the center and the corners separately? How we can connect them? That's going to be cool. I'm going to talk about many advanced tools here, so you can see that Grasshopper has many opportunities. You can control everything. So this is the first part, and let's talk about the second method. So you can have this algorithm, you can download it, but I'm going to disconnect this mesh and just move this part. Okay, and we need to just change everything, so let me just delete everything and go back to the first place. So here we are. We just talked about this. We had a point attractor, we had set of points of cloud of points, and we wanted to remap that. Graph mapper, again a remap, and move the points and make the surface. It was easy. Now we're going to talk about how we can control or divide the points and the cloud of points into two parts. Okay, you're gonna love Grasshopper, because this part is going to show you how you can simply just dispatch and use logics to make changes in your model. Okay, the first part is to make two sets of points in this point cloud, and there's going to be a center of points. We're going to control this, and the corners is going to be in the second part. So what I'm going to do is a technique that you can use to just dispatch items. You're going to use a remap, and I'm remapping this to 0 and 1, and after that I'm going to put a logic on it. We go to the math, and here we are. We can use a smaller and bigger. There are many other things, and I'm going to put this in a Grasshopper course about the gate and gate or. What are those? How we're going to use different logics to dispatch our in geometry or whatever we have. Okay, let's go for a smaller or larger than, and let's say that all of the distances between the attractor point and the point cloud is just remapped to 0 and 1. So we're going to say something like 25%. Okay, we're saying that those distances, which one are going to be bigger than to 0.25? So there are going to be some trues, and there's going to be some falses. Okay, there are true and falses. So there are points that are bigger than 25% and some that are smaller. So what I'm going to do is to use dispatch. The technique is to use dispatch to dispatch a list of data, list to filter. So I'm going to filter the points, and what is the pattern of dispatching is this one, a true and a false. It will give you two set of output, a true and a false list. So if I just disable the preview here, disable the preview here, and we have two set of points, the list A and the list B, and you can see that I can change the how those points going to be dispatched. And this is a really simple approach. You can just dispatch your points. We can have multiple logics combined with a and or, and we can also use geometrical logics, something like pointing curves. Is a point in a curve or is it not? Is a point in a B-rep or a B-reps or in a trim or not, and then produce a logic. Okay, so I'm going to first work on this middle center points, and you can see that it will just change by this. Okay, let me give it exactly in the center, another MD slider. Okay, so what we can do is to move these points. Perhaps we can again put a distance between these points and between these points and the point attractor. Again, we have a distance, and we use the remap, we use the graph mapper, we use the remap again, and move those points. Okay, I'm going to move and make these points move up to Z, and say the minimum and the maximum of the Z direction. Okay, we want something like this, because as you can see, we have a cone here, and we're going to work better than the previous one. Okay, so about controlling those points, we can use a graph mapper, a Bezier, and just change this. You can see that it's going to be easy. Okay, that's a better one. So we can easily change the distribution for only the middle center part of the point cloud, and I'm just going to put that off. Okay, and let me just go further and further. Okay, and the next part is going to be the corners. So we're going to work on the corners. It's exactly the same as this one, so we can just delete this point. Okay, just the Control C, Control V, copy and paste, and connect the list A to it. Okay, what we need here is to merge the points up here with the points down there. So it's really easy. We can use the minimum here, so it's about something like 1.70. okay, we're going to connect to the minimum and connect a maximum for this one. Okay, so you can see that it's being controlled by another one, but if you want the same height as this, you can just connect the 20.23 here. Okay, and you can see that it's going to change as the same height. That's okay. So we have more control on this. Okay, check this out. We can go up and change this one. We can move it. You can see we can control the height. So it's really easy, and we can have only 2 numbers to control all of this. You can see that it's just exactly, you can't see the scene, you know, it's exactly merging those. So okay, that's it. We are going to use exactly what we did, but there's a point here. We have 2 set of points. How can we combine them to have the we had the, okay, I've deleted that. We had the surface from points here. We have 2 set of points, and if we want to make a surface from these points, we can't give the U number because it doesn't have an U number. You can't give a 20 here. We you can't see any results. Those points are just messed up. So how can we just rearrange the points or combine them? There's a great tool that is called weave. We have to weave back the points. You know, we have dispatched them into two groups. Now we have to weave them back. So we have a weave here. Weave is going to combine and weave the stream of data with a pattern. So we have a stream 0, stream 1. You can just zoom in and have more streams. And I'm going to delete this and have two stream of data, and one is these points and the second is these points. Okay, 0 and 1. The pattern that we need is based on a 0 and 1. How can we achieve that? We can use the pattern we used before. Okay, here we had a true false. A true and a false is basically a 0 and 1, because if I just put a integer to the output in the main menu, okay, params menu, integer, you can see that it's a 0 and 1. So 0 is false and 1 is true. Yep, you can see this. So it will exactly weave back the data into 0 and 1. So I'm going to give this to the pattern. I have to check out which one is 0 and 1 by just connecting a surface and just changing the 0 and 1 source. So, and let's go back. I've talked about this, 49 for the U count and x plus 1. If we were lucky, we will have the surface. Okay, we had a misconception about the 0 and 1. Okay, so this is the 0, this is the 1. So you can see that that's the false and that's the true. So when we give we have to give the false to the 0. And what is the false? Here it goes, here it comes, and it goes to list B, and this is the dispatch target for false values. That's correct. So this is the dispatch for true values, and it comes here, and we go up to here, and it goes to 1. So that's the point for connecting the 0 and 1. Okay, I can just this off. You can see we have the surface. That's the second method you can use. You can also you had to see the Leo's video. It was great. You can see how you can use other methods to work with Grasshopper, learn more. And this is two more exercises you can see and work with it. And let me just connect this to the mesh surface, and we'll have it. Okay, preview off, and this is a new result because we just controlled the center. We can control the center, these graphs, and you can see that. You can see that here. Okay, and this is the result. Let me just turn this off. Put the surface. It's at the same height, but because we are just rebuilding it with mesh, you can see that. Okay, let me just make this. You can see that the results will seem a little bit downwards because the center is a little bit down. Okay, here we go. That's okay, and you can just give this to the contour and the shapes, and here we go. This is the result. This is the second way. Let me bake this. Okay, and here we go. We will have the resulting surface, and we had more control on this because the first one, I don't know if I had that. Okay, I don't know, maybe it's just okay, It was the first one. I have to change these. Let me connect this. So this is the second result. You can see that there are two different ways. You can control the center more with the dispatch pattern. You can weave it back and perhaps see the results. So in this tutorial I was just trying to teach you how you can use two different methods to produce this table. We will collaborate with Leo on other videos. Perhaps I will choose another one, the parametric brick wall, how you can model it another way. So this is going to be a collaborative video about how you can model a same thing but with different approaches. So it will be more exercise about one example, and if you have any comments or if you have any questions, feel free to put it underneath this video. And thank you for watching, and I will be back soon with another video about the brick wall pattern that is called the precedent parametric brick wall. You can just watch that and learn the methods that Leo has taught in the kinetic architecture channel. And if I had time, I will just record a video explaining how you can use another way to produce the brick wall. Thank you for watching.